Well, now I'm going to give a proposal for our final project. Our group consists of two members, Hong Xingyang and Lan Tingxie. Well, the first part of the proposal is the introduction of the project. Our project is aiming at making an application that can help recommend the best route to desired destinations in Calgary. Well, nowadays, people's daily lives often heavily depend on the use of private cars, which gives rise to heavy traffic congestion and increasing number of traffic incidents. The situation makes the time people spend on commuting become longer, and the safety level of driving become lower. In order to solve the problem, two open datasets, traffic incidents and traffic volume flow map, are imported to help with the route design. We use ArcGIS to cluster the traffic incidence data in order to get the coordinates of areas with high traffic incidents. And after the clustering process, we combine the clustering results with traffic volumes information to decide the risk level of the area. Well, as is mentioned, the first dataset we use is traffic incidents. Traffic incidents is an archive of traffic incidents within Calgary updated every 10 minutes. On the right side of the slide is an example of the data in datasets. It consists of the addresses and the coordinates of the location where incidents took place. Then another open dataset we use is traffic volume flow map. The traffic volume flow map illustrates the average annual weekday traffic. The average number of vehicles in 24 hours adjusted for seasonal variation to represent the average weekday. The numbers on the map are two-way totals. We can see that the roads are colored differently according to the traffic volumes of the road. Then comes the next part, the data clustering process. Clustering is an important branch of data processing. Efficient analysis of the traffic incidence data can help users justify the complex condition of roads quickly. In the project, ArcGIS is used to visualize the distribution of traffic incident places. In ArcGIS platform, a dual processing package clustering is provided to help cluster the important data. The results of the clustering process are shown here. The data in the table only shows part of the results actually. Then comes the second part, the design of the application. Well, first I will introduce the home page. Well, after running application.py, the user can get access to the home page of the website, on which the users can see a traffic flow map of Calgary. The roads are colored differently according to the traffic volumes. And after clicking the Incidents button, traffic incident information will be shown on the screen. Well, since the data of traffic incidents is too large, some of the markers may overlap or get in too close at certain zoom level. Therefore, overlapping marker specifier for leaflet and leaflet marker cluster are imported to solve the problem, and the examples are shown in the two pictures respectively. Then comes the login and registration section. Well, an online database is linked to the application to achieve the function of login and registration section. After setting up a PostgreSQL database, we use SQL command to create a table to store the information of users, including username, password, first name, and last name. User can get access to login page by clicking login on the top of the page. When the user is new to the website, he can get to the registration page to get an account by clicking Don't Have Account on the bottom of the login window. And the registration page is shown in the picture. The next part is the most important part, route design page. Well, after logging in, user can have access to route design section. The red circles with a car symbol on the picture are places with high traffic incidence rate. The information of these places comes from the results of the clustering process of ArcGIS, which is shown earlier. And the user can get a recommended route by clicking on the map. The first point the user click will be A, starting place, while the second will be B, destination. And the red points on the map are regarded as obstacles. After turning these points into turf objects, the Boolean disjoint function in turf will be imported to see whether the obstacle and the route collide or not. If they don't intersect, the result is true, which means the route is good, which is exactly what is shown as route 1. And if they do intersect, the result is false, which means the road is bad, just like route 2. This route goes through an area with high traffic incidence rate. And then comes the last part, is the interactive design. Well, in the login and registration section, message alert function is imported to inform the user whether their actions are successful or not. When their actions fail, the reason of their failure will be shown to help them solve the problem, such as what is shown in the second picture. Your password or username field is empty. Please return and fill in the form. And pop-up content are also added to the traffic incidence page and route design page. In traffic incidence page, users can get a date, description, and the exact address of the incidents by clicking the marker on the page. While in route design page, users can get a risk level and the number of incidents happened in the area by moving the mouse towards the car symbol. And the examples are shown in the two pictures. Well, that's the end of the proposal.